In this video, we will see about the QUCS software. QUCS is a quite universal circuit simulator which can be used for many of the circuit designs, analog, or digital circuit, linear circuits, nonlinear circuits, digital circuit simulators, and even especially using QUCS, we can able to design RF system circuits also can possible when compared to other simulators, LT Spice or even uh, T Spice and multi-sim, even many other simulators. This simulator especially easily utilized for the sake of analyzing S parameters for the RF circuits. So this software is mostly suitable for the RF system design tools for the students who are in fourth year under 23 regulation. So the student has to study about the RF design, software and tools designing, simulating RF systems, and he has knowledge about impedance matching circuits, scattering parameters, that is S11, S12, S21 and S22, and power values. Those things can be easily analyzed and sketched and plotted, can be done using QUCS software. So that is why we will see about in this video on QUCS, how to utilize this. So on screen, you can see the QUCS simulator. But before proceeding to this screen, let us see how to download the QUCS software. So first open the Google Chrome. There you can type for the QUCS QUCS software or a simulator. The version by default here it is showing a 0.019 version. You can click the download and go for the first link under source forge. It is available. So click this one and you can have an option called the download the latest version of the QUCS for the Windows 32-bit version. It is shows 48.2 MB. If you just click this one, by default, the download will start downloading the file into your window, into your downloads section. So you can, the file will be in the zip format. So you can extract that file and open that file. There is no need of installation and all. So once the file is downloaded, once the file is downloaded, then you can proceed to see the window or the folder will be like this QCS 0.019. Then open this one and directly you can see an icon called QUCS. Okay, Windows batch file. So double click this one, then you can able to see the QUCS simulator will be open. So on the top, you can see there are several sections will be available, starting with file, edit, positioning, insert, project, and so on. So majorly, we will be focused now in this video about left side of the panel. So here we can see the projects list. Now currently there are no projects has been created. So now that is why under project list, this is a empty. So if we want to create any project or if you want to do any circuit, first thing you need to create a project. So first click on the new button so that it will open a new window with asking for the project name. So I'm using with the name called project 1, then create. Once it is been created, then you can see under project a folder will be created. So under project 1, you can see several content will be available. So it is being switched from projects to content folder. So now you can see data sets, data displays, Verilog, Verilog A, VHDL. So hardware descriptive languages, octave, schematics. So what I said earlier, that analog circuits, linear, non-linear, digital circuits also can be designed. So this section is visible here. And the next one is a components. So here you can see under component section, on the top you can have a scroll down option. Just click that one. Then you can see lumped components, sources, probes, transmission lines, and so on. Under lumped components, you can see different types of resistors. One is a resistor and a resistor ES, capacitor, inductor, ground, sub-circuit boards, transformers, DC blocks, DC feed, phase simulators, hybrid. So these components will be available under lumped components. Then under sources, you can see DC source, DC current, AC source, AC voltage, there are different types of sources will be available. So for a general characteristic analysis of a diode or a transistor or a MOSFET or BJT, anything, we can go for the AC DC analysis. But if we want to study about S parameters, then the source should be power source. This is to be selected and it has to be placed here. And here you can see as it is being utilized, especially for the RF design, the impedance value will be chosen here. It is a 50 ohms. So this is a power source. If we want to edit this impedance value of the power source, then you can double click on it and you can edit the name of the power source. So that if we want to make it that it is to be connected for the input port, then you can use it as a name input port or any of the name. And the number of ports is being selected. And the Z value is ohms, 50 ohms by default will be there. If needed, we can able to change the ohms with respect to the impedance matching of the transmission line, either at the input side or at the output side. After editing, click apply and then OK. So power source is very important for the RF circuit design. So if whichever the impedance is been required based on the circuit design, we can change the impedance value. So by double clicking this one. So if editing is done, then apply and then click OK. This is the major source that is being utilized, and if needed for any of the circuit, we can go for the AM modulation and PM modulated circuits and all. We can use respective sources can be used from this source section. And there is a other one is probes. So this is for the current probe and voltage probe, where we can able to analyze the voltage and current. These two can be used. And next one is a transmission lines. We can see different kinds of transmission lines are available. A normal transmission line, if just double click and place it, line 1, here also we can have an impedance value and it is a length value is 1 millimeter. These parameters also can be changed, and we can see 4 terminal and a coupled one, twisted pair, coaxial, rectangular waveguide and substrate for the microstrip antenna. So several types of source transmission lines also available for the analysis of S parameters. And we have a nonlinear component section to analyze circuits for nonlinear oscillators, amplifier circuits, diode, NPN transistors. Also, we have several sources is available here. The next one is we can jump to the simulations. This has been utilized for the AC DC analysis transient. As we have been concentrating on the S parameters, we need to use the S parameter simulation, and it is to be placed here. And click on escape to remove this mouse pointer focusing another S parameter simulator. And if we want to edit this S parameters values similar to starting frequency, ending frequency, double click on it and you can change the value, start frequency, stop frequency, and the step value. And the number of points for the total starting to ending value is also can be editable here. And units also can be changed if required based on the circuit, whether from giga to mega or mega to kilo, whichever the value is be, that is also can be able to edit here. So after editing, the same procedure is to apply and then click OK. So S parameter simulator is this one, and the other one is the last one is the diagrams. So once the circuit is design completed, respective instruments to measure the parameters of S or any of the value, all the simulators instruments also has to be placed. Once this is done, then the next one is we need to go for the diagrams for the plotting. So the first you can see on the left side of the panel of the screen, it is a Cartesian graph, polar graph, and tabular Smith chart admittance. We have other tables also there. So if to analyze the S parameters with respect to power versus the value frequency, you can select this one and place it here. Once you place the Cartesian plot, you can have a content of data sets will be available. So currently there are no data sets has been selected in the schematic. So only just have it as a demo site. So it is not visible any of the S values or any ports is been not connected to the line of the circuit. So this is currently it is empty. So whichever the values has been in the schematic, those will be available in the data set. So you need to select this one that will be added under the graph section. Then click on apply and click OK. If we want to have the same within the same plot multiple S values, then you can have a multiple S values will be plotted with the different colors. That is also easier to analyze different S parameters comparing in the same plot. This is the use of Cartesian plot. So after completing all this, whichever the circuit is being plotted, and you can have an analysis of that circuit, RF circuit or any circuit. So that will be visible in the new window. Here, this is a schematic window with the name called untitled is been shown here. So if this has to be saved, then you can have an option called save option. So that will be saved with the schematic name. So currently we have created a project with the name project 1. Now under project 1, I am saving the schematic with the project schematic SCH. So by default extension file will be there. No need to change that file. You can have a click on it. Then the file of schematic will be changed here. So if you come back to the content list under schematic section, project schematic has been created. So whatever the data set also has, once it is created, that is also will be available under data sets or data displays, anything that is possible. And the schematic is done if there are no errors that can be verified using the simulator tool here. You can have an option here called simulate. So if we observed any check circuit connection errors or any of the other syntax errors, that is to be rectified. Without that, it cannot move to the plotting window. So plotting window is available in the next beside tab of the schematic. So that can be available only if the circuit is properly connected without any errors. And you can see there is another option called set marker on the graph. So if we want to plot, if we want to identify the S value, which you can have a good matching is updated for the less than minus 10 dB or minus 20 dB, that at that point, what would be the frequency that is easily identified using the marker window. So that is easily get a value, particular frequency, where you can get a good impedance value, what frequency. For the range, any of the set, here you can see 1 to 10 gigahertz. If I got a value of 2 gigahertz, a good value, at that point, if we want to mark, then click this one and place it there on the graph to get the value. So this is about the complete understanding about QUCS. So this is quite universal circuit simulator.